Hello everyone, this is Atharva Oak and now I'm presenting our final presentation. We are Group 95 and I'm presenting a project, our results and the outputs in general. So let's get started. So our project was facial emotion recognition using SVMs. So getting into this. So our problem statement was that we wanted to make a system that was able to understand and respond to human behavior more effectively. So whenever it sees a face, it should be able to recognize what emotion the person is facing in that specific moment. And as you can imagine, it has lots of applications in various domains. We have listed some of these here, like human-computer interaction, mental health monitoring, security and surveillance, education, autonomous vehicles. So you can think of a lot actually. And you can use them in autonomous vehicles is especially something that we can use in, especially with the advancements currently happening. Our objective was to train a SVM-RBF model, which stands for Support Vector Machine with Radial Basis Function. We, we wanted to train such a model in order to recognize facial emotions provided in a given image. So if I provided the image or if I show it in real time, it should be able to recognize what the person is thinking. So there are a few challenges here, like lighting variations, cultural differences, and resource constraints. So we had to do everything managing these constraints and challenges. So these are our data sources, so FDR 2013 and RA. FDR 2013 is more in grayscale, which with faces that are like at the very center of the image, and just it occupies about this. The face occupies about the same space in all images. Versus the RAFDB, it has like 15,000 images with seven different emotions, which you will see later on. And there's lots of variations in it, like age, gender, ethnicity, lighting conditions, and head poses. So moving on. So our input was from the data set, or the images from the data set that we just showed, with a file name and the label of that specific name. That was our input. And while doing pre-processing, what we did was we scaled the images appropriately, we cleaned up all the data set. In cleaning, I want to say like we removed all the images that did not contain faces, and we did this using a library called MediaPipe in Python. We augmented the images, we did some feature extraction and normalization, and then we started training them using the RBF SVM or SVM RBF model. So the characteristics of the specific model is that it maps input features into a higher dimensional space, which makes it effective for handling non-linearly separable data, which is of course very relevant in this specific project. We and what's special about this model is it has two parameters, hyperparameters called regularization and gamma parameter. So regularization controls the trade-off between achieving low error and allowing misclassifications, versus the gamma influences how much a single image or a single sample can have influence on the overall model trade. So while training this, the baseline model which we used was an SVM with linear kernel, so normal SVM, and the improved model was the R. And we played around with the hyperparameters just to see was there any optimization in the performance. While testing it, we did some testing on known data, which was just to make sure it's performing correctly and just to see its accuracy. We tested it on some unknown data, which included images of the teammates actually, just to see whether it's performing well in unseen test data. And the validation set was used mostly for optimizing the hyperparameters, which we mentioned just before. So after this, we are jumping into the confusion metrics of our final model output. So as you can see here, we're getting very high results while detecting fear, happiness, and neutral faces. But it's very interesting to note that neutral has some trouble distinguishing between sad and surprise as well. And the main reason was that um, these three emotions, neutral, sad, and surprised, are very close to each other, and that's why it will, of course, have some difficulties differentiating between the two. Otherwise, it gave. So these are our results of the same model over here, as you can see. So as you can see, got an overall accuracy of 78% with the precision of 79, recall of 78, and F1 score of 0.78. So these are the overall results for each individual emotion. So moving forward, we want to make sure that the images that the model is much more well trained. And also another thing we want to improve on is when you are when we take an image and if the person is to the is not at the very center of the image, the model won't be very highly accurate. So this is something we want to improve on. And these are references. And thank you for listening to us. And I hope you give us your feedback.